This month we do a repair to log. And if you don't know what log is, this is it right here. This is a Tom's Dolly build. Basically, it's a clone of a Prusa Mark II, but it's made out of wood. The gantry is 18mm oak plywood, and then the Y carriage is 6mm MDF. And one of the things always holding log back in the accuracy standpoint was this Y carriage. There's just a little bit of slop. You can see there's just a little bit of shimmy side to side, and that is not going to help your print accuracy much. And that's for a couple of reasons. One, it's because I cut this by hand with a jigsaw, so these holes are never going to be that accurate. But two, it's how MDF is made. MDF is layer by layer paper pretty much, so in the corners they don't stay all that sharp, and they tend to round and squash down, so over time that bearing is going to get loose. And the holes that hold the zip tie, they pull and are going to tear through that MDF. So I thought, this is 3D printing. Why don't we try to print a Y carriage? So that's what I set out to do. Now Prusa makes the files for these frames available on their GitHub in DFX format. Only problem is, DFX can't be printed until you turn it into an STL. It's a flat file. So that's what I want to tackle first. We need to turn that DXF into something we can print. So I'm going to jump over to my laptop where we have Fusion 360 installed. First thing we need to do is go out and get the Prusa DXF file. We need to go to the Prusa 3 Vanilla GitHub. And in the source directory, we need this alu-frame.dxf. So let's just back up one, and we'll just download the whole package. We can open that up. It's in the source directory. We can just copy this out to the desktop. And I already have one right here. So we have our DXF file. Now let's jump into Fusion. And if you don't know it, Fusion is free for makers. As long as you make less than $100,000 a year on Fusion, it's free. So don't be afraid to download it. So let's turn on Origin. Let's insert DXF. We'll select the origin. I'm going to select Z. We'll go find our DXF file. Now it says it brings it in millimeters, but it's actually 10 times too big. I'm not sure what I'm doing wrong here, but there's a pretty easy way to fix it because I know how big the frame needs to be. So I'll show you that in a second. We're going to bring it in as a single sketch so it includes the holes in the frame, but we're just going to get rid of the layers we don't need. We don't want the outside frame. We don't want the inside. We need the bed. We don't need the name. And we're going to keep all the holes, the dry holes and the ones that are threaded. So we'll go ahead and hit OK. Now that we have that, we can just get rid of all the holes that were in the outer frame since we kept them all. So we can just highlight, delete. We'll get rid of them all. Okay, now it's all cleaned up. We've got rid of all of the frame holes and we've kept the ones in the bed. Now if you click on your DFX object and you right click, you can do Edit Sketch. And this is going to show you how large this is. And this is saying that it's over 220 millimeters wide. And that's not right. These frames are about 220 squared. And if you have a Mark II heated bed, the old red PCB, they're 214 by 214. And they fit in these holes perfect. That's a great way to line up a pattern if you ever have to with paper. So we need to scale this down to 10%. So 1/10 of what it is now. So we'll stop sketch. We'll go to Modify, Scale. We'll select our entity over here, which is the sketch. And we want a uniform scale, and we're going to make it 0.1. That's 1/10 as big as it is now. So we'll hit OK. Now if we zoom in, so now this looks a lot more reasonable. And if we want to inspect it, we can measure. So we'll do Measure, and then we'll just measure hole to hole. Again, this fits a 214 millimeter square bed. So we'll measure from this hole to this hole over here. That's 209 millimeters. So those holes are going to be a little bit inset on a 214, so I know this is the correct size. So we've got our size correct. We can go ahead and close measure. We can select the whole thing, and these are 6 millimeters thick. So we can do E to extrude. We can put in 6 millimeters, hit enter. And you can see now it's 6 millimeters thick. Now all we need to do is save it as an STL. We'll click on it, hit make, 3D print. I'm going to unselect 3D print utility, and we'll hit OK. And we'll save this as frog bed. Squash frog is kind of a pet name for this frame. We'll save it. And let's head into Slicer. I'm going to print this on my CR10 because it's big enough to hold this frame. You could do it on a Prusa, but I'll go more into that in a second. I'm going to use PETG with no linear advance and 50% infill. So let's go ahead and add our bed. We'll go ahead and slice. We'll take a look at the preview, and we should be good to go. Now we have our STL file. All we have to do is print it. Now you could print it on log or a Prusa printer, but it's going to be really tight. You're going to have just enough room to get that on there. So that's going to take a lot more effort than I wanted to do, and I don't have to do that because I have other printer options. So I chose to print it on the CR10. So let's do that now. And this is what we came up with. I used IC3D PETG, 50% infill, and it came out pretty good. Now there is a little flex to this Y carriage because it is printed and it's only 6 millimeters thick. But in this configuration, since I'm not using bed springs, I'm using the Mark 42 bed, I think the combination of the two should make it plenty rigid and probably a lot more accurate than this MDF. So let's get it switched out. Looks like it travels pretty smooth. My Y carriage belt holder isn't in the best of shape anyway. Might as well replace it while I'm in here. I'll use a red one. Shh, we'll be the only ones that know. And I'm going to call that fixed. Now it's never going to be as sturdy as a 6mm aluminum Y carriage like it's on a Prusa, and it's not as stiff as MDF. But I guarantee it's a lot more accurate because I didn't have to cut it by hand, and it's going to be able to hold those zip ties a lot better. It probably would be better if I could find some U-bolts, and I might do that in the future. Now this isn't going to work with spring-loaded beds that you have to adjust, but since this is a Mark 42 bed and it's on standoffs, they work together and it should work just fine. And it's going to be a lot lighter. A big thanks to all my Patreon supporters. These videos are just for you, and I'll see you on the next coffee break.